Okay, so all of this information is available to both E&I and Russia. Uh, E&I presumes that if it contracts with Russia, the Russians will respond by demanding a bribe. So in this case, E&I would receive only $1 in that case. But if instead E&I goes to Norway, Norway will not demand a bribe, and therefore will permit E&I a profit of $2. Given those two options, E&I will choose to contract with Norway, and that will determine the game. Okay, so now we can determine whether the solution is a Nash equilibrium. Remember that we have a Nash solution if, if, if a given player is doing the best that he can, given that other players are also doing their best. In this case, let's investigate whether the contact with Norway is an equilibrium. Since Norway can do nothing but pass up on the bribe, that is its best strategy because it is the only strategy. And given that Norway does not demand a bribe, and Russia will, the best that E&I can do is to contact Norway rather than with Russia. So this is a Nash equilibrium. However, a Nash equilibrium is not necessarily the best of all worlds, even though it is the best that each player can do. There is a difference between the individual outcome and the social outcome. In this case, the solution is not efficient because the total value of the activity is only $3 in Norway, but it is $4 in Russia. So for some reason, maybe the oil field is more productive in Russia than in Norway. The Russian solution would have been socially optimal, but we don't provide added because the bribe is driving a wedge between the individual value and the social value. So no, this solution is not efficient. The Norway oil field is worth less than the Russian field and therefore should not be developed in preference to the Russian. And then for part D, there may be a variety of possibilities. For example, maybe E&I can commit to a strategy that would prevent the Russians from collecting a bribe. Maybe they can, for example, say that if the Russians collect a bribe, E&I will pull out of Russia. In that case, the Russians are losing the value of the oil field development. One way maybe of doing that is that E&I could put in a fund, let's say $2 billion, and it pledges to the supervisor of that fund that it will give up that amount if it permits the Russians to charge a bribe just one possibility. So the idea behind Part D is to come up with a credible commitment by ENI not to pay the Russian bribe. Okay, next problem. On other micro or macro.
Point B from the first question.
On macro.
Yeah.
Okay, so here is a total utility scenario, which is a non-linear income function, non-linear function of income. So marginal utility is first positive, but it's always positive that marginal utility is increasing for this segment and then decreases after the inflection point. So that means that at some point, the marginal utility is not changing. We have something like a linear segment in here. If marginal utility is constant, then that is a signal of this neutrality scenario. So let me put that on the whiteboard if that will help. Here is Marriott's utility function. If both levels of income, marginal utility is rising. You see that from the fact that the slope is steepening. And then for high income, marginal utility is falling. So since we have a continuous function in income, there is some point in the middle where marginal utility neither rises nor falls, but is constant. When income is low, Marriott is risk loving. When income is high, Marriott is risk averse. And when marginal utility is constant, Marriott is risk neutral. Okay, so far. Okay, uh, please go on with the next problem. Either one of you for either test.
I didn't. I didn't go over the test. So if Iqbal has any questions, he can ask, because I didn't have a time to look at them.
Okay, why don't you go ahead?
The last question from our last topic from microeconomics.
Last question in macroeconomics.
Right.
Question 11.
Yeah.
Okay. All right, let's go back down to the whiteboard. In this question, we have a production function. It depends on labor and capital. Those are the inputs. Now, remember that when we talked about growth theory in macroeconomics, we said that there are constant returns to scale. If each input is increasing by a given parameter, that will lead production or output to increase by the same parameter. So, for example, if we double capital and labor, then output will also double. Those are constant returns. So, by extension, we have diminishing returns to scale if doubling the input of leads to a value of y that is less than 2y. And what would suggest to do the case for increasing returns to scale? Now, if both inputs are doubling, then production will exceed 2y. Okay, so far. So in some sense, there is a wasting of inputs under diminishing returns to scale to have a fall off in production. Here is an example of diminishing returns to scale. As we increase budgeted capital, then Y also is increasing, but by less and less. So in this problem, we have that when capital and labor are tripling, the amount of production will rise only by a factor of 2. That is, up to the double, but it will not triple. So we must have diminishing returns to scale in this case. Okay, so far. All right. Next question. Anything on the medical exam? What about the medical exam?
Question 4 from Macro.
Question 4 on medical?
Yeah.
Okay, so we have an increase in uncertainty in Hong Kong. People are not sure what may happen under martial law. So aggregate demand will fall in Hong Kong. Therefore, if you want to sell oil, you should lower your price. Basically, to compensate people in Hong Kong for the uncertainty. So what happens in this case is that the risk is transferred from Hong Kong buyers to you, the exporter. On the question about the real exchange rate, let me know that there are a couple of ways that you can define the real exchange rate. And either one would be fine. But here is how I'm defining it in those particular questions. I'm using the market exchange rate of the number of tenge per dollar. And then I define the real exchange rate of the call this RER as the inverse of E times the price level in Kazakhstan divided by the price level in the United States. So, for example, if E rises, it seems to be the convention in Kazakhstan, then the real exchange rate will fall. This signals depreciation of the penny. and for that matter, so would arise in the price level in the United States. I note this because in the test book of Matthew, the real exchange rate is defined inversely because Matthew is defining the nominal exchange rate as the number of dollars per tenge. But integration, note what is happening in this case. 1 over E represents the number of dollars that a tenge can purchase. And then you take that amount, turns the price level into the sum, which is also measured in tenge. So in the numerator, we have a measure of Kazakhstani production in dollars per bundle. And then the price level in the United States, which is the price of a bundle measured in dollars. So the real exchange rate is converting a measure of Kazakhstani production so that it is possible to measure production in the United States per bundle. That's the basic idea behind the real exchange rate. It is measuring output rather than currencies, because everything is defined in terms of the same currency, the dollar. I think that will help you on the question about the real exchange rate on the backfill exam. But if you prefer to use Matthew's definition of the real exchange rate, which is inverse to mine, by all means go ahead and use it. Just redefine in your answer the nominal exchange rate. Okay, so this is the real exchange rate for Pakistan for the tenge. What about the real exchange rate for the dollar for the United States? Well, this is just the inverse of the real exchange rate for the tenge. If, for example, production is relatively expensive in Pakistan, then it is relatively inexpensive in the United States. So here is a nominal exchange rate, tenge per dollar, times the cost in dollars of U.S. production relative to the cost of production in Pakistan. So now we're measuring everything, both the numerator and the denominator, in terms of tenge. Okay, so far. Other questions? for either micro or macro. While you're thinking about it, let me take a moment to talk a bit about the Studsky equation in question number 7. I will go to the whiteboard. Just in case that you have not had time to read about the Studsky equation. The Studsky equation is measuring the impact of prices on demand. But it takes advantage of two different ways of measuring demand. First, there is the Marshallian demand function. For product X, good of service X. In the Marshallian view, the demand for X depends on the price of X, the price of substitute goods, and also on the monetary income. So that is the usual demand function in basic macroeconomics. Note that under Marshallian demand, utility may change along the function. We are not holding utility constant. So here is X on the vertical axis is useful, the price of X, and then we have for conventional goods a verb sloping function. You'll notice that in this function we are holding monetary income constant. However, utility is rising since people prefer to have more X and at a lower price per X. Utility is rising. As we move down, the Marshallian demand function. There is, however, another way that you can think about demand in terms of depiction of compensated demand function. So I will denote this as FC. This function also depends on prices. But this time we hold constant not monetary income, but utility instead. Utility is constant. Along this function. So where in Marcellian demand, rising income will shift out to the demand for a normal good. Like this. That is not the case for Hicksian demand. A way to think about this is in different terms. Substitute x and the substitute did y. Here is an indifference curve. And now we are thinking about the impact on the demand for x when the price of x goes down. For Hicksian demand, as the price of x falls, we move from a point, but A, right here, to a point like B, right here, on the same indifference curve. In other words, utility is not changing along the Hicksian demand function. However, income does. In contrast, again, looking at indifference curves, Marshallian demand does not hold utility constant. So here's one sloppy indifference curve. Here's another. And we now analyze in the same way a fall in the price of X on the amount of X that people want to buy. So we begin over here with a high price of X, and we are consuming at point A, the quantity right here. And now we permit the first of X to fall. So the dotted line scribbles out like that. Now we are consuming more X, although oddly enough, not more Y necessarily, right there at point B. And there is no Sheldian demand. Notice that utility has increased as the price of X has gone down, but that was not the case in pitching demand. There is the basic distinction between the two demand functions. Okay, good. So the structure equation takes both factors, both demand functions into account. In the structure equation, we look at the impact of price on X in the Marshallian demand function. This is equal to the impact on X of the price of X in the Hessian demand function with an adjustment for the income effect. So both price effects are negative. And if you have a normal good, the income effect GFGM will be positive. So notice what we have in the equation. The Marshallian or total price effect is equal to the substitution effect plus the income effect for X. To see this, let's go back to the Hicksian demand function shown with indifference terms. That looks a bit better. So when the price of X went down, we moved from point A from the point B. On the same utility function. Notice that all that we have done is to substitute the t for x for y and moving from A to B. So the Hicksian price effect is purely a substitution effect. That's the basic idea. So this number corresponds to the first term on the right-hand side of the substitute equation. In Marshallian demand, we have a substitution effect, but also an income effect as well. So let me illustrate that. So here we begin with a high price for X. The tendency occurs at point A. Next, we have a fall in the price of X. So the new tendency occurs at point B on a different indifference curve. Okay. We still have a substitution effect, even in the Marshallian case. To find the substitution effect, let us find the tendency of the bucket line that reflects the new low price of X along the same indifference curve. So see if I can draw this parallel. This bucket line is parallel to the new one. So it reflects the fall in the price of X, however, holds constant utility. attention about here. I'll call it C. Okay. So in moving from A to C, we have a substitution effect. The price of X is going down. So we substitute X for Y, the utility does not change. So here is the substitution effect. From X1 to X2. Right there. X2 minus X1. If the income effect occurs from C over to B. So notice that what happens when we compare B to C is that we hold the price of this constant at the new low level, but we have a rise in income that is reflected by a rise in the intercept of the budget line. The income effect is X3 minus X2. From here, let's approach the X1 over here. The Schwarzschild equation is adding the substitution and the income effect that is due to the change in the price of X. There is the substitution effect and there is the income effect. So those are the mathematics, but this is the intuition behind the income effect. But the idea is that if the price of rice is going down, then basically that price cut will raise your real income in the sense that you can now afford to buy more rice than before. That change in the real income affects your preferences. If rice is a normal good, then you will buy more rice as your income increases. In that case, GFGM over here is a positive number. So both the substitution effect and the income effect will reduce the demand for X when the price of X rises rather than falls. If that is normal. But if this will help, let me summarize the income effect. If the price of X falls, your purchasing power will rise. This affects the preferences. The demand for X will change as well. If X is normal, then the increase in purchasing power will raise the demand for X. A being solution is that if the price of tea goes down, then this will free up your money to buy a variety of goods that are normal, including tea itself. The price of tea falls, so you will spend the savings on many goods, including tea, if those goods are normal. The normality simply means that you want more tea when you're rich rather than poor. For example, steak is a normal good. As you become richer, you will want to buy more steak and less fewer hamburgers. Steak is a normal good, and hamburgers are an inferior good. So that is the intuition behind the income effect and the Subki equation. I hope that will help you with that question about the Subki equation. Okay, other questions? I can have a last minute review session if you want time to study on Sunday before I hand out the finals, if you would like. Okay, but you can let me know. Let's take a look for 1 minute at problem number 9. You remember that what we discussed in different spheres, we said that the consumer will maximize utility at the point at which the relative price of X is equal to the marginal value of X to the consumer, measured in marginal utility. Like that. Now, if we rearrange the expression, we maximize utility, then the ratio of marginal utility to the price is the same for both goods. So all that I've done is to rearrange this expression right here. The idea is that we want to spend our money in the way that will give us the biggest bang for buck, as it were. That we get the same value at the margin from a dollar spent on X as we do from a dollar spent on Y. So, for example, suppose instead that we had this inequality. Now, another dollar spent on X will give us more utility than another dollar spent on Y. So we should rearrange spending, spend more on X and less on Y. That's the basic idea. I'll take the money from X and Y so that another dollar could give you the same additional utility from either X or Y. That's the idea. So, for example, suppose that the limited utility of X is equal to 10, and the price of X is 2, the price of Y is 1, and the limited utility of Y equal to, let us say 4. Okay, then the additional utility of spending another dollar on X is 10 divided by 2 or 5 euros. However, for Y, the additional utility per dollar spent on Y is 4 minus divided by 1 or 4. Well, we are getting 5 euros if we spend on X, then only 4 euros if we spend that additional dollar on Y. So then the next dollar, which is the additional dollar on X, by cutting back on spending on Y by $1. We take $1 from Y, spend it on X instead, and we will gain 1 additional euro. By spending on X, we gain 5, but cutting back on Y, we lose 4. So there is a net gain of 1 euro. That's the idea behind this formula. Now, exactly the same thing is true when we're talking about production. So we have labor and capital as our inputs. The price of labor is the wage for the W, and the price of capital for the rent or R. And then the value to the producer of labor is measured by how productive the worker would be of the change in production relative to labor, called the marginal product of labor. So this is a lot like the market utility of X, except in this case, the consumer of labor is the producer, the employer. So the value of capital is, you would guess, the change in production relative to 1 more unit of capital. X is the production function. Okay, you, the producer, must decide how much labor to hire and how many machines to rent. How would you make this decision? Well, in the same way that the consumer chooses how much to spend on X and Y. You will allocate the money between labor and capital in such a way that you get the biggest bang per buck. That is, to increase your production as much as you can per dollar spent on labor or on capital. So this time, the tendency looks like this. If I were to denote this is FL, and this as FK. So the rule says that we should demand per dollar spent on labor the same amount of additional production that we could have had could be spent instead on capital. Or to put it another way, the number of product of labor relative to the wage is the same as the number of product of capital relative to the price of capital for rent. Now, suppose that condition does not hold, that instead the marginal product of labor relative to the wage is greater than the marginal product of capital relative to the price of capital R. What should you do now? As a producer, how can you increase production profitably in this case?
Buy more machines,
Let's say again,
hire less workers,
why?
because it will cost you more.
The price of labor is fixed. This is the wage. And the price of another unit of capital is R. So you can think about the value of paying another dollar for wages as the increase in production that would occur when you buy another labor hour. That value is the marginal product of labor. And the same thing for capital. So if a marginal product of labor is equal to 10, then you can increase production for 10 units, maybe 10 pizzas, by hiring another labor hour. So if the wage is $2, then the value of another labor hour that you purchase is 10 pizzas divided by the number of dollars that you spend, or 5 pizzas per additional dollar spent on labor. This basic idea. Right. Now suppose that the marginal product of capital is 3. Each additional pizza oven will provide 3 more pizzas, for example, and the rent is only $1. then the value of another unit of capital that you purchase would be the 3 pieces that you add to production relative to the price of the capital, or 3 pieces per unit of capital higher. So notice what is happening if you buy another hour of labor, you can add 5 pieces per dollar spent. But if instead you hire another unit of capital, you can add only 3 pieces per dollar spent on capital. So if 5 is more than 3, you should spend that additional dollar on labor, not on capital. Take a dollar away from the owners of capital and spend it instead on labor. But that's the idea. Notice that, contrary to popular opinion, it is not always best to produce in countries, for example, that have low wages. What matters is not the wage itself, but the increase in production that the additional wage can afford for you. Compare what you get per dollar spent on labor or per dollar spent on capital. So the moral of the story is that if the producer should have always tried to produce in low-wage countries, instead compare the value of production in, let us say, Mexico to the value of production in a hard-wage country such as the United States. $12 spent. If American workers are so productive that your investment pays off in the United States, build the factory in the US and not in Mexico. Low wages are not the end of the story. People don't look to the bidding in return for the low wage. Okay, so I think that will help you with lesson number 9.